Hello everyone, I'm Teacher Michelle and welcome to another episode of Unang Math. In this episode, we will be dealing with the applications of repeating decimals. In our previous episode, we already studied what repeating decimals are, how to identify the repeating block of a repeating decimal, and how to represent those repeating blocks. In this episode, we will be solving worded problems as an application of this topic, and I will be sharing tips on how to solve these problems. Okay, let's start with the first one. The fraction 5 over 11 expressed as a decimal. We will find the 30th digit after the decimal point. In order to find the 30th digit after the decimal point, the first thing we need to do is we have to convert 5 over 11 to decimal number. And probably this decimal number is a repeating decimal number. Okay, let's do it. So it's going to be 5 divided by 11. 5 divided by 11 is 0. So 0 point and then add 0 here. So 50 divided by 11. This is 4. 4 times 11 is 44. 50 minus 44 is 6. Add another 0. So 60 divided by 11 is 5. 5 times 11 is 55. And then 60 minus 55, this is 5. Okay, if you're going to take a look at this one repeats. So our repeating decimal number is 0.4545 and so on. The repeating block is 45. And if we're going to represent that, it's going to be 0.45. Draw a line on top of 4 and on top of 5. This problem is asking for the 30th digit after the decimal point. So 4 is our first digit, 5 second digit. So this is third digit, fourth digit, fifth, and then sixth digit. If you're going to take a look at this one, 1, 3, 5, these are odd numbers. 2, 4, 6, these are even numbers. 30 is an even number. That means the 30th digit after the decimal point is 5. Okay, now, let's move on to the second problem. What is the 30th digit after the decimal point of the repeating decimal 3.4171717? So the repeating block are digits 1 and 7. So if we're going to represent that, so 3.417, draw a line on top of 1 and on top of 7. So this problem is asking for the 30th digit after the decimal point. Okay, after the decimal point, we have this digit 4. So this is our first digit. Second digit is 1. Third digit is 7. Fourth digit is 1, so fourth, and then fifth digit is 7. So this is 6, and this is 7th digit. Okay, if you're going to take a look at this one, 2, 4, 6, these are even numbers. 3, 5, 7, these are odd numbers. 30 is an even number. So that means the 30th digit after the decimal point is 1. Okay, now, let's move on to the third problem. What is the 150th digit after the decimal point of the repeating decimal 1.364 and so on? Okay, now, the repeating block have digits 3, 6, 4. So there are 3 digits. Okay, we cannot use this time the strategy of odd numbers and even numbers because we have 3 digits in our repeating block. So in order to find out what is the 150th digit, our strategy is 150 divided by 3. 3 here is the number of digits in our repeating block. So 150 divided by 3. This is equal to 50. 50 means this 364 or this repeating block is repeated 50 times. Okay, we don't have any remainder here. So that means our 150th digit is 4. Okay, what about if it's asking for the 125th digit? Okay, let's see. So it's going to be 125 divided by 3. 125 divided by 3, this is equal to 41 because 41 times 3 is going to be 123. So there is remainder 2. So if we're going to find what is the 125th digit, okay, that means this repeating block repeats 41 times. So this is like 123rd digit. Okay, we still have 2. So 124, 125. So 125th digit is 6. So in this kind of problem, the important thing is you have to divide. So the given divided by how many digits are there in our repeating block. And you have to consider the remainder. If there's a remainder, you have to include that in counting to find out the correct 150th digit or the 125th digit. Okay, now let's move on to our last problem. When fraction 4 over 27 is converted to a decimal, find the sum of the digits from the first to the 20th place after the decimal point. So this problem is asking us to find the sum of the digits from the first to the 20th place after the decimal point. So first thing we need to do, we have to convert this fraction 4 over 27 to decimal number, specifically to a repeating decimal number. Okay, let's do it. 4 divided by 27. 4 divided by 27 cannot be. So 0 point and then 4 here. 40 divided by 27. This is equal to 1. 1 times 27 is 27. So 40 minus 27, this is equal to 13. Okay, add 0. 130 divided by 27, this is equal to 4. 4 times 27, this is equal to 108. Okay, let's subtract. 130 minus 108, so this is gonna be 22. Okay, add another 0. So 220 divided by 27, this is equal to 8. Okay, 8 times 27, this is 8 times 7 is 56. So 6 is here. 8 times 2 is 16 plus 5, so it's going to be 221. So 216. Okay, let's subtract 220 minus 216, 4. Okay, if you are going to take a look at this one, okay, this one repeats. So our repeating decimal number is 0.148, 148, and so on. So the repeating block are digits 1, 4, 8. And if we're going to represent that, it's going to be 0.148. Draw a line on top of 1 and on top of 8. Okay, now, find the sum of the digits from the first to the 20th place. Okay, first thing we need to do, 20 divided by 3. Again, 3 because there are 3 digits in our repeating block. So 20 divided by 3, this is equal to 6. And there is remainder 2. Okay, now, that means 148 or this repeating block repeats 6 times. So sum of the digits from the first to the 20th place. So 1 plus 4 plus 8. We have to multiply this one by 6. Okay, plus, since we have here remainder 2, so it's going to be 1 plus 4. Okay, 1 plus 4 plus 8, this is equal to 13. So 13, okay, so it's going to be 13 times 6 plus 1 plus 4. 13 times 6, this is equal to 78. So 78 plus 1 plus 4, 78 plus 5, this is equal to 83. So the sum of the digits from the first to the 20th place after the decimal point is 83.